Yes, ma'am.
Okay. 1 by 3 plus 7 by 3i plus 4 plus 1 by 3i. Okay. When we will simplify it, this 7 by 3 and 1 by 3, we can just take these two together, and it will be 1 by 3 and 4 will be keeping together, and I you can take out common, and you can think about the basic simple calculation, 7 by 3 plus 1 by 3. However, the next part, whatever it is there, we'll copy over here, minus 4 by 3 plus I. Okay, let's continue. Now, if we will add 1 by 3 plus 4, what are we going to have? Yes, Alina. 1 by 3 plus 4 will be what? Please do it in rough space and let me know. 1 by 3 plus 4 is what? Yes, Ali and Alina. This 1 by 3 plus 4 is what? LCM will be 3, right?
Yes, ma'am.
And in numerator, what will be there? 1 plus 12. Is it so?
Yes, ma'am.
Okay. Plus I. 7 by 3 plus 1 by 3 is 8 by 3, right?
Yes, ma'am.
Okay. Minus is there. It's fine. Minus 4 by 3 plus I. Let's continue. Here we'll be having 12 plus 1, that is 13 by 3 plus 8 by 3i minus of minus 4 by 3, that means plus 4 by 3, right? Minus I, right?
Yes, ma'am.
Okay, let's open this curly bracket also. See, we have to collect all the real part together and we have to add them. Now we need to collect all the imaginary part together and we have to do the simplification. That's it. If we will keep on doing like this, we will end up getting the result 13 by 3 plus 4 by 3. 13 plus 4, 17 by 3. 8 by 3 minus I. Okay, this 8 by 3 minus I, it will be 17 by 3 plus 8 minus 3 by 3. Everything is having I along with it. Any confusion, Ali and Alina? See,
No, ma'am.
basic calculation, we just keep on doing the basic simplification. 17 by 3, 8 minus 3, that is 5 by 3i. And this is the final answer because we are done with writing it in the standard form, that is a plus ib. If the question will be what is the real part, what is the real part over here, Ali and Alina? And what is the imaginary part?
5 by 3 plus I.
Real part is what? Imaginary part is what?
17 by 3 is the real part.
Imaginary part?
5 by 3 I.
Yes, while saying imaginary part, I we will not say. We will just say this is 5 by 3. Now, once we will say that imaginary part is 5 by 3, the person, whoever will read this, whoever will just to whoever you are saying, they will understand that it is imaginary part. That means it is attached with I. Okay, so we don't have to say I when we are saying imaginary part. Okay,
Ma'am,
yes.
ma'am, how did 8 minus 3 by 3 I come?
Okay, so we have done the simplification over here, Ali. 8 by 3i minus I. Suppose you have taken I common. Okay. Suppose you have taken I common. So we are left with 8 by 3 minus 1. Yes or no?
Yes, ma'am.
Now 8 by 3 minus 1. What will be the LCM over here? Ali, what will be the LCM? This type of fractional subtraction we have to do by taking out the LCM, right? What will be
Yes,
the
ma'am.
LCM?
3.
Yes, 3. In numerator, what will be there, Ali?
8 minus 3.
8 minus 3. So that's what I have written, right?
Yes,
Getting
ma'am.
it?
Yes, ma'am.
Okay, this question Alina asked. I have given this question as a homework and how to do the simplification over here. That's what we were discussing. That this is how we will just take real part together one by one. We will keep on doing the simplification. Then we will take imaginary part and we will keep on just imaginary part we will do the simplification together. Real part we will do the simplification together. And hence at last we are getting 17 by 3 plus 5 by 3. I. Is it clear? Let's do this question. Evaluate I to the power 18 plus 1 by I to the power 25 and everything is having power 3. Let's evaluate the value from here. I told you I to the power whatever will be there, you always try to write it in the I square to the power anything, whatever it will be possible. So I to the power 18 को कैसे लिख सकते हैं? I square के क्या पावर होगी ताकि 18 क्रिएट कर पाए हम लोग. ये सली है नहीं. आई स्क्वायर का पावर क्या लें कि आई टू द पावर 18 क्रिएट कर सके हम लोग?
9.
9. Okay, perfect. Here we are having 1 by I. Here power is 25. We know law of exponent says that distribute the power. So numerator will take 25 power, denominator will take 25 power, and outside power 3 is there. We will just take it as it is. Okay. Now I square is nothing but minus 1, right? Minus 1 to the power 9. We will think about it. But at first, let's write it as it is. 1 to the power 25, it is just 1. 1 to the power anything is just 1. Now in denominator, we are having I to the power 25. Now can you tell me I square के क्या power लिखें कि 25 create कर पाए और अगर नहीं create कर पाए तो क्या करना होगा यहाँ पे? Please tell me. Aliya नहीं.
12 plus 1.
12 plus 1. That means one more
Plus
I
I.
we can write, right?
Yes,
Into
ma'am.
I, right? So we are having minus 1 to the power 9. Minus 1 to the power 9 is what? Plus 1 or minus 1? Minus 1 ka 9. If the power is 9, then will it be plus 1 or minus 1? The final answer. ध्यान से देखो
-1.
पावर ऑड है. Yes, odd power है तो result minus होगी. Plus 1 by I square to the power 12 is there. I square is minus 1. Minus 1 to the power 12 into I is there. Okay. Power 3 is there. Step by step we are solving it and we are trying to figure it out what will be the final answer. Okay. So here we are having minus 1. Here we are having 1 by minus 1 to the power 12. 12 is an even number. Minus 1 to the power even number. That means the result will be plus 1 or minus 1. Yes, the result will be plus 1 or minus 1.
Plus 1.
Plus 1. And I into I is there. So just I will be remaining. Okay. Here power 3. Now what we will do? We will try removing I from the denominator because we know that A plus IB format, I is always sitting in the numerator. So is there any way to remove this I from the denominator? Yeah, we know that when we will do the multiplication of I and I over here, which is allowed, we are not changing anything. Okay. which is allowed, then we will be able to remove I from the denominator. This way we will be able to make I square in the denominator and just I in the numerator. And this denominator's I square will be minus 1, and we are left with minus 1 plus denominator is minus 1 over here. Here just I whole cube. Now this two sign combined together, this two sign combined together will be negative. Yes or no? Yes or no, Ali and Alina? Minus 1 minus I can be right. Whole cube.
Yes, ma'am.
Okay. Now we can use the formula A minus B whole cube. But while using the formula, we have to be careful. Our A is minus 1. Our B is just I. And hence we are using the formula A minus B whole cube. Okay. So A is minus 1 and B is just I. Formula is A cube minus B cube. Here minus, tell me, what shall I write? Yes, the previous class we were talking about this formula A minus B whole cube. Yes, what shall I write over here?
Ma'am,
What was the
minus
formula?
a cube minus 3a square b plus 3ab square minus b cube.
Yes, so minus 3, A is minus 1 square, B is just right, plus 3, A is minus 1, B is square, that means I is square. Any confusion? So we are having minus 1 whole cube, that is just minus 1 because the power is odd. Okay, minus this minus 1 square is just 1. So minus 3I we can write it. Here I square is there. We will be able to write it as a 3 into minus 1 is minus 3. Let's write minus 1 as it is because I square is also minus 1. And I cube is I square into I, right? Any confusion? Earlier minus 1 minus 3I. Okay, this negative 1 positive, so it is just becoming only 3. Here we are having I square, that is minus 1 into I. Okay, so minus 1 minus 3I plus 3. Here we are having plus I. Did you see it? So minus 1 plus 3. Just a moment, no, are we doing any mistake? Because it says to evaluate. And whenever this type of evaluate based question comes in, then the answer must be 0, 1 like this. Just a moment, let me match. Then we are on the right track. Okay, let's continue. 3 minus 1 is 2. Minus 3I plus I is minus 2. Any confusion? Ali and Alina, this is what we ended up getting. We have written it in the form of A plus IB. If the question will be what is real part, it's 2. What is imaginary part, it's minus 2. Yes or no? Any confusion, Ali and Alina? Yes,
No, ma'am.
any confusion? Okay, let me take the next question.
Ma'am, can you show this question? I didn't write it.
This one is the question. Now tell me, I will keep on scrolling.
I'm gonna scroll down. Little more.
Like this, down, right?
Yes, ma'am. Ma'am, down. Done, ma'am. Ma'am, done. I'm done.
So the next question is reduce 1 by 1 minus 4, right? Minus 2 by 1 plus I. 3 minus 4i over 5 plus I in a standard form. Yeah, let's continue. We have to reduce it in a standard form. That means a plus ib format we have to reduce it. Now this one here simplification we must be comfortable with the simplification part. Can you see that in the bracket term we can do the simplification? Like first we need to take out the LCM, then we have to do the subtraction. Can you see it, Ali and Alina? If I will ask you what is the LCM for the bracket term, can you tell me what is the LCM? Ali and Alina, either you find LCM now only, okay, like this, and then proceed. Otherwise, the next possible option is you do the rationalization over here only. That is 1 minus 4i is there. Here only do the rationalization. Then it will be easier for you to continue and to think about the LCM. So here only will be if we will be doing the rationalization, 1 minus 4i is there, we will do the multiplication of 1 plus 4i by 1 plus 2. Okay, minus 2 by 1 plus I is there, we will do the multiplication in this particular fraction only, 1 minus I by 1 minus I. Why we are doing so? So that we can remove I and all from the denominator. Okay, and the next term we will, for now we can keep it like this. At first we can focus on solving the bracket term, this the first bracket. Okay, so if you will do this step, then you will see that here a minus b a plus b have created purposefully. It is a square minus b square, and in numerator just 1 plus 4i is there. Here a minus b a plus b we have created, so it is a square minus b square, and in numerator just 2 1 minus I is. Okay, this is what we are. Here we are having 3 minus 4i by 5 plus 8. Any confusion so far, Ali and Alina?
No.
Okay, now we can write it as a 1 square is just 1, and this will be minus 16i is 1. 1 minus 16 is fine, but beside that I square is there, which we can substitute the value minus 1. Okay, here 1 is okay, minus I square can be taken as minus. Okay, here we are having 1 plus 4i, and here we are having 2 in bracket 1 minus I, or you can open the bracket, you can say it is nothing but just 2 minus 2. Okay, and one more part is there, we will be thinking about that, but let's work on this part at first. Here we'll be having 1 plus 16, that is 17. 1 plus 4i will be there in the numerator, minus 1 plus 1, that is 2. Still I will be asking you what is the LCM. 17 and 2, what is the LCM? Earlier, Alina, what is the LCM? Curly bracket we need to simplify. Yes,
30.
34. 17 2 times 34, so 2 we need to multiply with this numerator. 2 17 times 34, so 17 we need to multiply with this numerator. Confusion so far, Alina?
No, ma'am.
Let's open the bracket. 2 plus 8i minus 34 plus 34i by 34. This is what we are. 8i, 34i, 42i, and 2 minus 34 is what? Yes, Ali and Alina, 2 minus 34 is what? Yes, 2 minus 34 is what?
Minus
Minus
30.
32.
Minus 32. Or we can write minus 32 plus 40. I doesn't matter. Now this one, 3 minus 4i 1 plus 9. Still we need to do the multiplication. What if here also we will do rationalization at first? So we will be able to remove I from the denominator. Basically what we have to do here, we have to write it in the form of a plus ib. So if I is there in the numerator, fine, but not, we don't want I in the denominator. So we can do the rationalization now only. We can say that we are multiplying with 5 minus I and 5 minus I. Okay, here 3 minus 4i is there. Let's do it. 3 minus 4i. Anyhow, we have to apply distributive property and we have to do the multiplication of these two brackets. But the denominator is now sorted. It will be 5 square minus I square. Okay, this curly bracket will remain as it is. 42i minus 32, you can say, or minus 32 plus 42i, it's the same thing. Okay, now let's do the apply the distributive property. 3 into 5, 15. 3 into minus I, minus 3. Minus 4i into 5, minus 20i. Minus 4i into minus I plus 4i square. Any confusion, Ali and Alina?
No, ma'am.
This is what we are getting. Here we'll be having 42i minus 32 by 34. Now we'll be having 25 plus 1, 26. In numerator we are having 15 is there and 4i square, that means see 15 is there, 4i square. I square is just minus 1. Minus 4 is there. 15 minus 4 is 15 minus 4 is, are you
11
getting back? Yes. And minus 3i minus 20i will be
minus 17i.
now we have to apply distributive property. Before that, we will see if anything can be taken out from numerator part common so that we can simplify. We can use the smaller number rather than 42, 32. So 2 can be taken out common. Anything else? Or 4 can be taken out common. No, 2 can be taken out common. Okay. Yeah, nothing can be taken out from it. So now we will do the multiplication of numerators. Okay, in denominator, of course, we have to do the multiplication. But for now, we can also keep it like this. We have to multiply the numerator basically. 21i minus 16. And this 11 minus 7. Okay, let's do it quick, quick, quick. So 21i we will multiply with 11. 20. It will be 231. Check it. Check it now.
Two 31.
Then 21 we will multiply with 7. It is minus 7. 47. Okay, 21 I with 7 I we are doing, so I square. Minus 16 we are multiplying with 11. See, there is a trick whenever you are multiplying a 2-digit number with 11. The trick, the Vedic maths trick says that if you are multiplying this number with 11, then the result will be 1, 6 and 6 plus 1, 7. Okay, similarly, we have multiplied this 21 with 11. So Vedic maths, there is a short trick which says that for multiplication with 11, that 2 will be there, 1 will be there, and then this addition of 2 and 1, that is 3 will be there. Getting it?
Yes, ma'am.
Okay, so many tricks are there. This is just the very smaller trick. But in Vedic maths, so many tricks are there. Okay, let's continue. So 21, 16 and 11, I said to you it will be 176. If you want, you can check it. 16 into 7, we have to do the multiplication. 16 with this minus 16 with minus 7. So plus 6, 7, and so to 2 carry 4. 112i. Yes or no? Now we will just combine I with I, and I square means nothing but just minus 1. So this will be plus 147. Okay, this will be minus 176. This is just 231i, and this is 125. Please do the simplification early and tell me the final answer. 'Yes, what are you getting?
1 by 17 into 26 into 343 I minus 29.
If we wanted to write it in the form of a plus ib, now check anything is possible to take out as a common factor. No, no. Okay, so yeah, we will just distribute this denominator. We can write it 343 by 17 into 26. You can do the multiplication, that I minus 29 by 17 into 26. So basically we are having our real part in a plus ib format. If you will write it, it is this. This is our real part plus 343 plus by 17 into 26 I. This is our imaginary part. A plus ib format we have created. Is it clear, Ali and Alina? See, we have not done anything else. Just we kept on doing the simplification, and this type of question can also come in exam. This is just concept based, right? Is it clear? Our A is this huge number and B is this function. If it is clear, can we proceed? Can we continue? Now we'll be discussing algebra of complex number. How to write any given expression in the standard form of complex number, that is a plus I. You understood? When we are having any expression where I to the power like 20, 30, or maybe 100, whatever be the power of I is there, how to deal with such scenario, we learn that. Okay, now we are going to discuss what is algebra of complex number. Now recall, when you have learned the chapter whole number, maybe in very lower class or integer, you that time only you learned that whether it is whether whole number will follow the commutative property for addition or not, whether it will follow closure property or not, whether it will follow associative property or not. Same way for complex number also we are going to discuss whether the complex number, that means in a plus ib format, if we are having real part, imaginary part combined together is making complex number, this complex number will follow these properties or not. Okay, so one by one we will discuss. So the first property is in terms of addition of two complex numbers. At first, we will be talking about all the property with respect to addition. Okay, so the first property is closure property. We also call it closure law. You just have to understand. Okay, this type of question, um, most of the time you will be able to just fill in the blank space question, true false space question can come from here. Okay, so closure property, what that property says, when you are having a complex number z1, for example a plus I, okay, and z2, yeah. So if z1 is a complex number, which is for example looks like a plus ib, and z2 is another complex number which maybe looks like c plus ib, I will be showing you with the help of example. Then z1 plus z2, okay, for example rather than taking a plus ib and c plus ib, let's take z1 is 3 plus 4i, okay, and z2 is z2 is suppose 7 plus 8i. Okay, these are the two different complex number we have taken. Then the addition of these two complex numbers z1 plus z2, we can add them like this: 3 plus 4i plus 7 plus 8i. Like this we can do the addition, and here we can add the real part with real part, that is 10, and the imaginary part with imaginary part, that is 12i, which is again a complex number. This is also a complex number. So closure property says that when we are adding two complex number, the result will also be a complex number. It's just like the whole numbers closure property. When you will be adding two whole number, the result will always be a whole number. Always. You take any two whole number, always when you will add both of them, and whatever result it will generate, it will be whole number. Okay, similarly here also, whenever we'll be taking two complex number and when we will add them, of course we'll be getting the answer as a complex number. Okay, that's called closure property. This property basically says that when you have taken one complex number, another complex number, okay, this is a complex number, this is a complex number, when you have added them, then the result, this which represents z1 plus z2, like combined form it represents. Okay, this combined form is also a complex number. That's what the property says. And yes, we can see it with the help of example also. Is there, like, are you understanding what the property says? Ali and Alina, are you understanding what exactly the property is trying to say?
Yes, ma'am.
Ali, are you getting? Yes,
Yes, ma'am.
Ali, are you getting it? Yes. So this is our closure property. Okay. From here, max to max, like this is the actual scenario. We have solved so many questions like this. We are now only we have added real part with real part, imaginary part with imaginary part. Basically, those calculation we are doing since we know this closure property. But I have taught you the calculation part at first, that we can do real part and real part can come together, can get added together, can get subtracted together, and imaginary part can get added together, subtracted together. First I shown you the practical, and then I'm showing you the theory. Okay, this is the theory. From here only we are doing everything in practical, that we are adding both the real part, we are subtracting the real part, we are adding or subtracting the imaginary parts. So yes, complex number plus complex number will make a complex number. If the question, suppose I would have taken this example, that suppose z1 is a plus ib and z2 is c plus id. Okay, this two added together, when we will add z1 plus z2, still it will be a complex number. How? Let me show you how. We can write this a and c real parts together, and we can say, of course it will be a real part only. A is a real number, c is a real number, both added together will be a real number only. And ib and id we can write together, that ib plus id, I we can take out common, and it will be b plus d. It will be imaginary part. So yes, complex number plus complex number, the resultant is a complex number. Yes or no? If someone will say, what is the real part? That is a plus c. What is the imaginary part? That is b plus d. Yes or no? Yes or no? Ali and Alina.
Yes, ma'am.
Okay. So you just need to understand. Nothing else. Let's move ahead. The next property is commutative property. You must have heard this name, commutative property. With respect to addition, we are discussing all the property, which says that z1 plus z2 and z2 plus z1 is the same thing. Okay, whatever way you do, you will be getting the same answer. And we know that we have done a lot of questions, and we have realized that whatever way we write, at the end we are going to do the simplification of real part with real part and imaginary part with imaginary part. And that's what the commutative property also says. If z1 will commute to z2's place and z2 will commute to z1 place, and the result will not change. Do I need to show it to you that the result will not change? Yes.
No, ma'am.
You understand, the result will not change. Again, if I will take z1 as a 3 plus 4i, z2 as a 7 plus 8i, both added together is making 10 plus 12i. Now if we will be doing first writing z2 and then writing z1 and then we will add, still the result will be 10 plus 12i. Okay, I don't need to show you because you have done so much of calculations and simplification like this. Next property is associative, which says that if we are having three different complex numbers z1, z2, z3, then if you will be adding z2 plus z3 at first and then you will be adding z1. Bodmer says solve the bracket at first, right? So first you will be adding z2 plus z3. Whatever result you got, that result you are going to add with z1. Or at first you add z1 plus z2 and then add z3. Final result for both of them will be same. Okay, we understand that final result, of course it will be same, right? Is there any doubt, Ali and Alina?
No, ma'am.
This one we need to discuss, additive identity. Now additive identity means, suppose we are having a complex number z. Z means, let's take one example, 2 plus 3. In this complex number, let's add something. Additive means add something. Additive means add something in this complex number so that the identity of this complex number will not change. That means the result will be the same complex number, same, 2 plus 3i. Let's add something in this complex number so that the final identity will not change. That's what this terminology, additive means added, identity means identity must not change. That is zero only. Yes or no? Yes or no?
Yes, ma'am.
Now this 0 can be written as in the form of complex number. On day 1 I was telling you that 0 can be written as 0 plus 0 I. We can write it in the form of complex number. We can represent it in the form of complex number. Here real part is 0, imaginary part is 0. Yes or no?
Yes, ma'am.
Okay, that's why we say 0, or
Yes, ma'am.
0 plus 0 I is the additive identity for any complex number. For any complex number, 0, or rather than saying only 0, we will also say that 0 plus 0 I, this is a complex number. This is additive identity for any complex number. What does the meaning of additive identity? जब भी ये terminology आए additive identity किसी true false question में, किसी fill in the blanks question में, तो याद करना एडिटिव का मतलब होता है ऐड, आइडेंटिटी का मतलब होता है आइडेंटिटी चेंज ना, और ऐसा एडिटिव आइडेंटिटी का मतलब ऑफ कोर्स 0 ही होगा. कोई ऐसा नंबर ऐड करो कि z ही रह जाए, जो कॉम्प्लेक्स नंबर हमने लिया था वो सेम ही रह जाए. So that can be only 0, which can be written in the form of complex number, that is 0 plus 0. Okay, is it clear? Now the next is additive inverse. Now in your book it is written like that. This there exists the complex number 0 plus 0 I called additive identity or 0 complex number. And why it is called? Then the explanation, little bit of explanation also. We have discussed the same, right? That there exists a additive identity, that is 0 plus 0 for any complex number. For any complex number, additive identity will be the same, that is 0 plus 0, or you can also call it just only 0, right? Any confusion so far, Ali and Alina?
No, ma'am.
Now we'll be discussing about additive inverse. Additive inverse. Here also this terminology additive is there. That means let's add something to a given complex number. Okay, a given complex number, that is maybe 5 plus 3i. Let's add something. Okay, but inverse we need to add. Inverse means, do you understand that inverse means opposite? Inverse means opposite. When I will ask you what is the inverse of the fraction 1 by 5, you will say 5 by 1, right? Yes or no? Inverse, reciprocal. These are the terminology which somehow indicate opposite. Yes or no?
Yes,
Again,
ma'am.
okay. So here we are talking about additive inverse. Add something, but that has to be inverse. That means opposite. That has to be opposite. Okay. So opposite of this z will be minus z. 5 plus 3i, this one's opposite, inverse will be minus 5 minus 3i. This will be added to the given complex number and the result will be 0. So additive inverse एक ऐसा complex number है जो कि given complex number में जब भी add करेंगे तो result 0 आ जाएगा. गिवन कॉम्प्लेक्स नंबर में उसका एडिटिव इनवर्स जब भी ऐड करेंगे तो रिजल्ट 0 आ जाएगा. अब एडिटिव इनवर्स क्या होगा? अचानक से मैं कोई कॉम्प्लेक्स नंबर लिख दूं 2 plus 3i और मैं पूछूं कि इसका एडिटिव इनवर्स क्या होगा, तो -2 -3 है. यही एक कॉम्प्लेक्स नंबर है जो इसमें ऐड करेंगे तो रिजल्ट 0 क्रिएट करेगा, हाँ या ना? Yes or no? Are you getting it? What is the meaning of additive inverse? In whole number also this concept was there, additive inverse. 5 का additive inverse क्या है? -5. क्यों -5 है? क्योंकि -5 ही एक ऐसा नंबर है जो 5 में ऐड करेंगे तो रिजल्ट 0 आएगा. Hence this is called additive inverse. And the same concept is there in complex number. Such a complex number which added to the given complex number and the result will be 0. So anytime in any question, if additive inverse is asked, will you get confused if I will ask you what is the additive inverse of -3 plus 5? Ali and Alina. Yes, Ali and Alina, what is the additive inverse of this one?
5 minus 3i.
Yes, 5 minus 3i. Whatever you are having, just put minus sign in front of that and open the bracket. It will be it was already -5, so minus minus will be plus, just 5 minus 3. This is the additive inverse of the given complex number. When you will add this complex number with the given complex number, hence the result will be 0. Getting it?
Yes.
Okay. So we are done with discussing everything with respect to addition. Now we'll be discussing the same properties with respect to multiplication. Let's continue with this. Just give me a minute. A minute. Just give me a minute. So we'll be discussing all the property with respect to multiplication. Two complex number. When you will be taking one complex number, you will multiply it with another complex number. The result will be still a complex number. Closure property, that when we are taking one complex number multiplying with another complex number, the result is still a complex number. Okay, let's continue. Next property was commutative property. Commutative, which says that z1 into z2 and z2 into z1 is the same thing. Okay, when we will do the multiplication z1 with z2 like this, or when we will do z2 into z1, the result will be same. We know that. Okay, commutative property hold for multiplication of two complex numbers. Now next, associative property. There are three complex numbers z1, z2, z3. z1, z2, z3. If z1 and z2 associate together at first, and then z3 will be there. Or if z1 will be just sitting beside, and z2 and z3 will associate with each other at first. Okay. Still the answer will be same. Finally, you are multiplying z1 with z2 with z3. That's it. Answer will be same. Next we need to discuss multiplicative identity. Now you are having a random complex number. I am taking the example. Let's multiply a complex number with it so that the identity will not change. Multiplicative identity means let's multiply a complex number so that the identity will not change. Z will remain Z only. What can be multiplied? 0, 1 or what? अली एंड अलीना, ऐसा क्या मल्टीप्लाई कर सकते हैं z में कि z z ही रह जाए? Yes,
1.
1 is multiplicative identity. You can take any complex number, 3 plus 4i, 5 plus 6i, whatever complex number you take, and if you will multiply 1, 1 means we can write it in the complex form. Okay, complex numbers form we can write it. 1 can be written as 1 plus 0i. ओके, सो ये 1 प्लस 0i या फिर ओनली 1, जो भी बोलो, दिस इज अ मल्टीप्लिकेटिव आइडेंटिटी फॉर एनी कॉम्प्लेक्स नंबर. आर यू गेटिंग इट? Getting
Yes,
it early and early. Now multiplicative inverse. Multiplicative inverse. If we are having a complex number, let's multiply inverse with this complex number. Inverse means opposite, okay, or reciprocal. These are the synonymous word for inverse. Now only we were discussing about that. So for addition we were taking the negative. Okay, z with negative z we were taking because we were talking about adding both of them. And for addition the result was 0. Okay, both the complex number added together must generate 0. Here the multiplicative inverse, what must be multiplied over here so that the result will be 1. Z में क्या मल्टीप्लाई करें कि रिजल्ट 1 हो जाए? यस, Z में क्या
1 by z.
मल्टीप्लाई करें? एग्जैक्टली Z में 1 बाई Z ही मल्टीप्लाई करेंगे तभी जाके रिजल्ट 1 होगा. तो Z का अगर मल्टीप्लिकेटिव इनवर्स कभी भी पूछे तो हम लोग बताएंगे कि 1 बाई Z इज द मल्टीप्लिकेटिव इनवर्स. लेट्स टेक वन एग्जांपल. Z के प्लेस पे अगर 3 प्लस 4 आई है, इसका मल्टीप्लिकेटिव इनवर्स निकालना है तो हम लोग बोलेंगे 1 बाई 1 प्लस 3 प्लस 4 है, ये है मल्टीप्लिकेटिव इनवर्स गिवन कॉम्प्लेक्स नंबर का. बट आंसर ऐसे ही नहीं लिखेंगे, आंसर कॉम्प्लेक्स नंबर के फॉर्मेट में लिखेंगे, स्टैंडर्ड फॉर्म में. एंड वी नो 1 बाई 3 प्लस 4i को कॉम्प्लेक्स नंबर कैसे बनाते हैं. वी नो दैट. क्या करते हैं? रैशनलाइजेशन वाला लॉजिक अप्लाई करते हैं. ये मल्टीप्लिकेटिव इनवर्स है. We know that. Okay, this is the multiplicative inverse for 3 plus 4i. But as say, this way we cannot leave our answer. So for that we are going to do simplification. How we will do the simplification? What we will do? We will multiply 3 minus 4i with the denominator and numerator as well. So in numerator we ended up getting 3 minus 4i, and in denominator a square minus b square structure successfully we have created. Okay, so we are having 3 minus 4i in the numerator, and in denominator 3 square is 9. 4i, this is 16i square. Okay, 9 I square value we know it is minus 1, so it will be plus 16. 3 minus 4i. Okay, it will become 3 minus 4i by 25. Let's separate it to write it properly in the standard form. So we'll be saying 3 by 25 minus 4 by 25i. This is the complex number. Here the real part is 3 by 25 and imaginary part is minus 4 by 25. So multiplicative inverse of 3 plus 4i is this. Multiplicative inverse of this. Can you see it, Ali and Alina? कैसे निकाल रहे हैं मल्टीप्लिकेटिव इनवर्स आ रहा है समझ में?
Yes, ma'am.
Alina, are you getting?
Yes, ma'am.
We are saying multiplicative inverse is 1 by z only, but we cannot leave our answer like that. Hence, we are doing all this simplification. Okay. Hence, in your book, one statement is there that multiplicative inverse of z is equals to a plus ib whenever we are having. Multiplicative inverse of this one is, it's written directly, that is a by a square plus b square plus b by a square plus b square I. This is the multiplicative inverse of a plus I. This is the multiplicative inverse of a plus I. कहाँ से आया ये वैल्यू? कहाँ से आया? लॉजिक से आया. लेट मी शो यू. मल्टीप्लिकेटिव इनवर्स का मतलब क्या होता है? 1 by z. 1 by z means 1 by a plus ib. This way we cannot leave our answer, so we must have multiplied a minus ib in numerator and denominator. If we will do so, the denominator will become a square minus ib whole square. Right? Can you hear me? If my voice will become low, please tell me, because it is giving the signal of low battery. I have to remove it. Okay, let me remove it. Yeah, so we are having a minus ib in the numerator, and this is what we are having in the denominator. A minus ib as it is in the numerator, and denominator will become a square minus this b square and I square. I square is nothing but just minus 1. So in denominator it will be a square plus b square, because I square is minus 1, and in numerator it will be a minus ib. If you will separate it, see, you will be getting a by a square plus b square minus b by a square plus b square into I. This is what directly is written in your book, that this is the multiplicative inverse of a plus ib. कहाँ से आया ये? It just came from 1 by z, the concept only. Are you getting it, Ali and Alina? So every time direct formula we will not apply. We will apply the logic. Okay, whenever we have to find the multiplicative inverse, let's do it for few questions. Find
Ma'am, can you scroll up?
Yeah, sure. More? Alina?
Yes.
Little bit more or this much only?
Little bit more.
Is it okay?
Yes, ma'am. I'm done. Done.
Let's continue. So the question is find the multiplicative inverse of each. First question is 4 minus 3i. We know the multiplicative inverse of 4 minus 3i will be 1 by 4 minus 3i. Yes or no? Ali and Alina, yes or no? Z, the multiplicative inverse of Z was 1 by Z. So multiplicative inverse of 4 minus 3i will be 1 by 4 minus 3i. Haya na?
Yes, ma'am.
Now we will do the simplification. We will try removing this I from the denominator. So for that we need to do the multiplication of what can be multiplied, Ali and Alina?
4 plus 3.
4 plus 3i by 4 plus 3i. It became 4 plus 3i in the numerator. It became 4 square minus 3i whole square in the denominator, which will be 4 plus 3i in the numerator and in denominator 16. Okay, and 3i square will be minus 9i square. Now we will continue. I square we know it is minus 1, so 16 plus 9 will be there. 4 plus 3i will be there in the numerator and it will be 4 by 25 plus 3 by 25i. This is the final multiplicative inverse of 4 minus 3i. Is it clear, Ali and Alina?
Yes,
Yes,
ma'am.
ma'am.
Okay. If we have to find the multiplicative inverse of root 5 plus 3i, we know the multiplicative inverse will be 1 by root 5 plus 3i. Okay, now we will try eliminating this I from the denominator. For that, what we need to do the multiplication over here, Ali and Alina?
Root 5 minus 3i by root 5 minus 3i.
By root 5 minus 3i. Okay, now the denominator became root 5 square minus 3i whole square and the numerator is just root 5 minus 3i. Now we will continue. It will be, the numerator will be root 5 minus 3i and the denominator root 5 square will be what? Ali and Alina.
5.
Just 5? Yes or no?
Yes.
Yes, ma'am.
Okay, and 3i square? I square is just minus 1, so plus 3. We are done. We are done. We are getting 8 in the denominator. Here we are getting root 5 minus 3i. Now we can separate it. We can write it in the form of a plus ib, a complex number. So root 5 by 8 minus 3 by 8i. Okay. This is the multiplicative inverse of root 5 plus 3i. Okay. Now the last question over here is minus I. What is the multiplicative inverse of minus I? So we know minus I is there, whatever is there, Z is there, no? We need to create 1 by Z. It is Z, right? So 1 by Z. This is the multiplicative inverse. Yes or no? Ali and Alina, yes or no?
Yes.
Now we will try eliminating this I from the denominator. For that we will multiply I and I in the numerator and denominator. So denominator became just minus I square and numerator is just I. Okay. So I square is minus 1. Minus of minus 1 is plus 1. So just I we are getting. Okay. Just I we are getting. We can say that this is the multiplicative inverse of this minus I. Now ध्यान से सोचो, multiplicative inverse का मतलब वो ऐसा कुछ multiply कर दे कि result 1 आ जाए. और ध्यान से देखो ये दोनों आंसर को, माइनस आई क्वेश्चन में था और आंसर मल्टीप्लिकेटिव इनवर्स हमने आई फाइंड आउट किया है. ये दोनों को मल्टीप्लाई करेंगे तो हाँ रिजल्ट 1 जेनरेट होगा, हाँ या ना? माइनस आई को आई से मल्टीप्लाई करेंगे तो रिजल्ट 1 जेनरेट होगा. यस और नो? माइनस आई को आई से मल्टीप्लाई करेंगे तो रिजल्ट 1 जेनरेट होगा. यस और नो?
Yes, ma'am.